NASA's Explorer-1 space probe, the farthest venturing space probe ever launched, has confounded its watchers on its journey through the universe for nearly 50 years. Voyager 1 has been sending back critical data from the farthest reaches of the universe, mostly shaping our understanding of space. However, persistent transmissions from this astonishing spacecraft have presented baffling signals that have left the entire space community in a state of wonder and bewilderment. These signals have sparked discussions about whether they are the result of a technical error or if they could indicate something far more remarkable, perhaps extraterrestrial activity. Join us as we dive deeper into the mysteries surrounding these cosmic transmissions and uncover what might be hiding in the depths of space. The legacy of humanity's space exploration. Humanity's curiosity about the mysteries beyond our planet has been a key driver of space exploration since its inception. This insatiable curiosity led to groundbreaking missions like Pioneer 1 and Voyager 2, which were among the most ambitious space endeavors of their time. The launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977, marked the beginning of a new era in space exploration. Just a short time later, on September 5th, Voyager 1 followed, setting the stage for an unprecedented journey. These twin spacecraft, each weighing around 720 kilograms, roughly the size of a small car, were sent on a unique trajectory toward the outer planets, which played a crucial role in their orbits and mission outcomes. Throughout their extraordinary odyssey, these space probes traveled in different directions and at varying speeds. Voyager 1 overtakes Voyager 2. A significant moment occurred on December 15, 1977, when Voyager 1 overtook its twin due to differences in their paths. Since then, Voyager 1 has emerged as a critical asset, providing groundbreaking data that has transformed our understanding of the universe and its many phenomena. Before we delve into Voyager 1's latest astonishing discovery, which has captured the attention of the entire space community, let's revisit some of its most remarkable achievements. Voyager 1's key discoveries. In 1978, during its Jovian imaging mission, Voyager 1 was positioned about 265 million kilometers from Earth. By January 1979, it embarked on a groundbreaking 100-hour mission, capturing a time-lapse film of Jupiter's rotation. This series of 3,750 images provided unprecedented views of Jupiter's dynamic atmosphere and its complex features. The probe's discoveries included the identification of a thin ring around Jupiter, 2 previously unknown moons, significantly expanding our understanding of the gas giant's intricate system. To ensure the spacecraft's safe passage and avoid potential collisions with Titan, one of Saturn's moons, corrective maneuvers were performed. Beyond the planets, Voyager's interstellar mission. After successfully completing their planetary missions, scientists decided to direct both Voyager 1 and Voyager 2 beyond the limits of our solar system. Traveling at an astounding speed of 325 million kilometers per year, Voyager 1 officially began its interstellar mission in January 1990. During this period, it made significant discoveries, including identifying 4 additional moons, Mimas, Enceladus, Tethys, and Rhea, capturing some of the most iconic images ever taken of our solar system. On February 14, 1990, from about 6 billion kilometers from the Sun, Voyager 1 embarked on a historic photographic journey called the Family Portrait, capturing breathtaking images of the inner planets. Voyager 2's milestones. Meanwhile, Voyager 2 achieved remarkable feats of its own, including recording wind speeds over 13,100 meters per second on Neptune, the fastest ever observed in our solar system, providing crucial insights into Neptune's extreme environment and its largest moon, Triton, whose frigid surface temperature drops to minus 391 degrees Fahrenheit. Discovering ice volcanoes on Triton, which erupt nitrogen gas and propel frozen particles 5 kilometers into the atmosphere. These extraordinary findings have greatly expanded our understanding of the diverse and complex nature of celestial bodies in the outer solar system. The unprecedented impact of the Voyager missions. Both Voyager 1 and Voyager 2 revolutionized space exploration by revealing that Jupiter's and Saturn's moons, once thought to be heavily cratered and geologically inactive, are actually dynamic worlds with ongoing geological processes. Voyager 2 achieved another historic milestone, becoming the first and only spacecraft to fly by Uranus and Neptune, extending Voyager's lifespan. To prolong the operational life of these ambitious probes, NASA implemented various techniques, including shutting down unnecessary heaters and systems to conserve energy, carefully managing power consumption to keep essential instruments running. The Voyager mission is expected to conclude by 2030, marking a bittersweet moment for the engineers and scientists who dedicated their careers to this extraordinary endeavor. The ingenious engineering behind Voyager. The design of Voyager 1 and Voyager 2 was a marvel of engineering. The spacecraft were designed as stable platforms, rotating at a rate 10 times slower than the hour hand of a clock. This design choice minimized visual blurring as the probes traveled across the vast expanse of space. Even before reaching the outer planets, the probes began transmitting images of Jupiter, revealing its swirling clouds, the Great Red Spot, a massive storm that fascinated NASA scientists. However, one of the most astonishing discoveries was Io's volcanic activity. The probe's instruments detected strange signals from Io, later confirmed by striking images showing towering volcanic plumes and a landscape scarred by eruptions. One of Io's most prominent volcanoes erupted with a force 100 times greater than that of Mount St. Helens, covering an area nearly the size of France. The spacecraft's final journey. As the probes continued their journey, their cameras were eventually shut off to conserve power before venturing into interstellar space. Despite this, the images they captured remain some of the most significant ever taken. Beyond the Voyager probes, NASA launched other groundbreaking spacecraft, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11, becoming the farthest spacecraft from Earth. However, in the absence of other probes to observe its progress, Voyager 1 continued its solo journey for another 14 years before officially entering interstellar space on August 25, 2012. The genius of gravity assist maneuvers. The success of the Voyager missions was made possible through ingenious techniques, particularly gravity assist maneuvers. These maneuvers allowed the spacecraft to conserve fuel, achieve the necessary speeds to explore distant regions. By leveraging the gravitational pull of planets, Voyager 1 and 2 could slingshot their way across the solar system with extreme precision. For example, as Voyager 1 approached Jupiter, the planet's immense gravitational pull significantly increased its speed. Looking to the future, as we reflect on the incredible journey of these pioneering spacecraft and the wealth of knowledge they have provided, we eagerly await further updates on the investigation into Voyager 1's latest anomalies. Both Voyager 1 and Voyager 2 continue their missions beyond known boundaries, uncovering new discoveries and pushing the limits of human knowledge. For decades, Voyager 1 has continued to transmit data from the outer reaches of the heliosphere, the vast bubble-like region of space dominated by the sun's influence. However, in recent years, NASA scientists have detected unusual signals, transmissions that do not match anything previously observed. These signals have sparked intense debate within the space community. Could they be the result of a malfunction in Voyager's aging systems? Or do they point to something unknown, possibly even an encounter with an interstellar phenomenon? Deciphering the bizarre signals. In late 2022, NASA engineers noticed that Voyager 1's telemetry data was no longer making sense. The probe was still receiving and executing commands, but the status reports it was sending back were garbled and incomprehensible. After months of troubleshooting, engineers determined that the issue stemmed from the Attitude Articulation and Control System, ACS, the system responsible for keeping Voyager's antenna pointed toward Earth. Oddly, the ACS was still functioning, but sending its reports through an unknown computer system. By early 2023, the team successfully corrected this issue, restoring normal communication. However, the anomaly raised new questions. Why did the spacecraft reroute its signals in the first place? Was this an isolated glitch, or a sign of deeper system degradation? While some scientists believe the error was due to the aging hardware and decades of exposure to cosmic radiation, others have speculated about the possibility of external interference. Could Voyager have encountered an unknown interstellar force? Voyager's journey through interstellar space. As Voyager 1 and 2 continue their trek beyond our solar system, they are traveling through a region of space never before explored by human-made objects. This territory, known as the interstellar medium, is filled with charged particles, cosmic rays, and magnetic fields from distant stars. Scientists have already made groundbreaking discoveries, including the detection of cosmic tsunamis, shock waves from supernovae that ripple through interstellar space, a sudden unexplained drop in cosmic ray intensity, suggesting the presence of an unknown structure or boundary in deep space. Each year, Voyager 1 moves about 500 million kilometers farther from Earth, sending back invaluable data about the nature of interstellar space. The challenge of aging technology. Despite their resilience, the Voyager probes are aging and their power supply is dwindling. Both spacecraft rely on radioisotope thermoelectric generators, RTGs, which convert the heat from decaying plutonium into electricity. Over time, these generators produce less power, and NASA has had to gradually shut down non-essential systems to conserve energy. In 2019, engineers turned off Voyager 2's primary heater for its cosmic ray detector, yet the instrument continued to function at temperatures lower than ever thought possible. By 2025, it is expected that the probes will no longer have enough power to operate scientific instruments, marking the beginning of the final phase of the Voyager mission. Could we ever reconnect with Voyager? One of the most intriguing questions is whether future space missions could someday catch up to Voyager 1 and 2. While these probes are traveling faster than any human-made object before them, advances in propulsion technology, such as nuclear fusion drives or light sails, could allow a future spacecraft to intercept the Voyagers, retrieve their data, or even upgrade their systems. Such a mission would be decades away, but it remains a fascinating possibility. Voyager's final message to humanity. Even after their instruments shut down, Voyager 1 and 2 will continue drifting through interstellar space, silent ambassadors of Earth. Each probe carries the golden record, a time capsule containing sounds and music from Earth, including greetings in 55 languages, images of human life, nature, and scientific concepts. A message of peace, in case extraterrestrial life ever discovers it. These records are designed to last over 1 billion years, meaning that long after Earth itself has changed, Voyager may still be out there, carrying a snapshot of human civilization across the cosmos. What's next for interstellar exploration? While Voyager 1 and 2 are nearing the end of their missions, they have paved the way for the next generation of interstellar explorers. Future missions such as Breakthrough Starshot, a project aiming to send tiny spacecraft to Alpha Centauri at 20% the speed of light. Interstellar Probe, a NASA concept mission designed to travel 10 times farther than Voyager. These initiatives promise to push humanity even farther into the great unknown, continuing Voyager's legacy of discovery. Conclusion: a journey without end. The Voyager mission remains one of humanity's greatest scientific achievements. What began as a grand tour of the outer planets has transformed into a journey through interstellar space, uncovering cosmic mysteries along the way. As Voyager 1 and 2 drift farther into the unknown, their legacy endures, inspiring future generations to reach for the stars. And who knows? Perhaps one day, in the distant future, another intelligence, human or otherwise, will stumble upon these ancient explorers and hear the echo of Earth's first message to the cosmos. Pioneer 1 and Explorer 2 wandered into interstellar space to gather information on the immense cosmic climate. This continuous examination keeps expanding our knowledge of the universe beyond our solar system. As we anticipate more data about Voyager 1's latest signals and their potential implications for our understanding of the universe, the astonishing journey of the spacecraft remains a source of inspiration and interest for scientists and space enthusiasts alike. Their historic achievements continue to push the boundaries of human knowledge and exploration, highlighting the boundless potential of space discovery. The Explorer missions have provided us with a treasure trove of information about our solar system and beyond. In addition to their iconic images and data, the spacecraft also carried a remarkable record, an extraordinary artifact designed to share the story of our world with extraterrestrials. This record contains sounds and images chosen to represent the diversity of life and culture on Earth. It includes greetings in 55 languages, music from various cultures, and a selection of natural sounds such as thunder and whale songs. This message in a bottle, in a way, reflects the hope that, one day, if intelligent life exists elsewhere, they may find and understand it, offering a glimpse into humanity's essence. Voyager 1 and Voyager 2 were equipped with scientific instruments that transformed our understanding of space. These instruments included magnetometers, plasma wave detectors, high-energy particle detectors, and imaging systems, each contributing essential data about space phenomena. For instance, the magnetometers provided insights into the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, revealing the complex interactions between these planets and their surroundings. The plasma wave detectors helped us understand the nature of the solar wind and its relationship with planetary atmospheres and magnetospheres. One of the most remarkable aspects of the Voyager missions is their ability to measure the heliosphere boundary, a vast bubble of solar particles and magnetic fields that surrounds our solar system. As Voyager 1 approached the edge of this boundary, it detected a sudden change from the solar wind to the interstellar medium. This data has been instrumental in shaping our understanding of the heliosphere structure and its role in protecting Earth from cosmic radiation. The spacecraft's observations provided evidence of a distinct boundary where the solar wind slows down and becomes denser, known as the termination shock. Beyond this point lies the heliosheath, a region where the solar wind interacts with the interstellar medium, creating a complex and dynamic environment. Voyager 2's journey has been equally significant. After its successful flybys of Jupiter, Saturn, Uranus, and Neptune, it has continued to provide essential data on the outer reaches of our solar system. Voyager 2's observations of Uranus were particularly striking, revealing a unique magnetic field that is significantly tilted compared to the planet's rotational axis. This discovery challenged existing models of planetary magnetism and prompted further research into the magnetic conditions of other celestial bodies. Beyond their scientific contributions, the Voyager missions have had a profound impact on public interest in space exploration. The stunning images of distant planets and their moons, combined with the personal stories of the spacecraft's journeys, have captured the imagination of people worldwide. The photographs of Saturn's rings and the detailed views of Jupiter's moons, especially Io's volcanic activity, have inspired countless individuals and have been featured in educational materials, documentaries, and popular media. Building on the success of Pioneer 1 and Voyager 2, the scientific community has continued to make progress in space exploration. With advancements in technology, new space probes and telescopes have been launched to observe distant regions of the universe, seeking answers to many unanswered questions left by past missions. These innovations have allowed scientists to study distant exoplanets, black holes, and galaxy formation in unprecedented detail. For instance, the Hubble Space Telescope, launched in 1990, has provided some of the most famous images of the universe, revealing the birth of stars, the nature of nebulae, and the collision of galaxies. The study of exoplanets has become one of the most exciting areas of research in recent years. Thanks to the Kepler Space Telescope and other observatories, astronomers have identified thousands of exoplanets, some of which may have conditions suitable for life. By analyzing the composition of their atmospheres, scientists hope to determine whether any of these planets have the potential to harbor life. The discovery of a habitable zone around distant stars has fueled discussions about the possibility of finding extraterrestrial life in the future. Although no direct evidence has been found yet, research continues. The exploration of black holes has also seen groundbreaking advancements. These mysterious objects, whose gravitational pull is so strong that not even light can escape, have long fascinated scientists. In 2019, The Event Horizon Telescope, EHT, collaboration made history by capturing the first-ever image of a black hole located in the Messier 87 M87 galaxy. This remarkable achievement was the result of combining data from multiple radio telescopes around the world, creating a virtual Earth-sized telescope. The image provided direct visual evidence of a black hole's event horizon, marking a milestone in our understanding of these enigmatic objects. Moreover, the development of new space missions, such as the James Webb Space Telescope (JWST), promises to revolutionize our knowledge of the universe. Launched in 2021, the JWST provides unparalleled infrared observations, allowing scientists to study the formation of stars, galaxies, and planetary systems in greater detail than ever before. The JWST is also expected to contribute to our search for habitable exoplanets. Its instruments can analyze the atmospheres of distant worlds, looking for signs of water, oxygen, and other potential indicators of life. In addition to these scientific advancements, space exploration has become increasingly global. Space agencies around the world, including NASA, the European Space Agency (ESA), and China's CNSA, are collaborating on ambitious projects. These include the planned return of humans to the Moon under NASA's Artemis program and missions to Mars, such as NASA's Perseverance rover and China's Tianwen-1. The growing cooperation between nations in space exploration is not only advancing our understanding of the universe, but also fostering a sense of global unity and shared perspective. As we continue to push the boundaries of space exploration, the discoveries made by past missions, such as Voyager 1 and Voyager 2, remain foundational. These early missions paved the way for today's ambitious endeavors and continue to inspire future generations of scientists, engineers, and space enthusiasts. With each new discovery, we are reminded of the vastness and mystery of the universe and our endless drive to understand our place within it.